Today we're going to be simplifying rational expressions. Remember from previous conversations that rational, that word, means that it can be something written in the form A divided by B, where B can't equal 0. So that's just fancy words for saying it's something that can be written as a fraction. And when we're simplifying rational expressions, we're just simplifying fractions. So if you remember from the past, if we had something like 4/6, and I ask you to simplify that, both of those numbers are divisible by 2, so that would simplify to be 2/3. Okay, so that's one thing that that's the major thing that we're going to be doing with these, is simplifying fractions. Now, another major piece that we need to talk about is the difference between a monomial and a polynomial. Remember, a monomial is something that does not have any addition or subtraction signs. So something like 5x squared y, that is a monomial because there's no addition or subtraction signs there. A polynomial would be something that does have, so if we had something like 5x squared plus 3, there is a plus sign there, okay, which means that's a polynomial. So as you're going through and we're simplifying these, here we can look at each of these pieces individually, and these are free to cancel. Okay, monomials are free to cancel. You can look at individual parts of them and cross them off. Polynomials, however, because there's this addition sign, or if it's subtraction, those need to be kept together, and you cannot just cross off parts of those. Okay, we have had some conversation about that in class in the past. Okay, so let's look at a question, something that we've actually seen recently in our last unit. So if we're simplifying 12x to the third y to the third divided by 16x y to the fifth, this is just a monomial divided by a monomial. So we can look at each of these pieces individually and simplify them. Now, one thing we also need to keep track of is our restrictions, okay? So remember, in a fraction, the denominator cannot be equal to 0. So what things would create or make this equal to 0? I guess more so this denominator. We need to think about that, and we'll come back to that here momentarily. So with this, if we have 12/16, both of those divide by 4. So 12 divided by 4 is 3. And 16 divided by 4 is 4. So that simplifies to be 3/4. Because we have a fraction here, and we're going to use our exponent rules, we're going to subtract those exponents. So x cubed divided by x would give us x squared. And then y to the third divided by y to the fifth. The 5 is bigger, so we're subtracting again using our exponent rules, and we get y squared. So there's the first part of our answer. Okay, that's the simplified part, that right there. The second part, like I was talking about before, is the restrictions. We need to state what would make the denominator equal 0. Well, 16 is just a number. There's no variable with that, so you don't need to do anything there. Here we could say, or we should say, that y can't equal 0, because if we take 16 times 0 times something, whatever y is, that would make that denominator 0, not allowed to happen. Similarly, if we have y equal to 0, okay, 16 times whatever x is times 0 would be 0, and we're not allowed to have that. So these two parts are your answers. So I'll box the simplified version, and I'll put a circle around the restrictions. You have to make sure you're finding the restrictions back with the original question, or else you're going to lose some of those restrictions. So if we did it over here, we would have lost the fact that x can't equal 0 is a restriction that we need. Okay? So what if we look at something like this? So now we have x squared plus 7x plus 12 divided by x squared plus 4x. So you're going to be very tempted. You cannot just cross off parts of these. These are polynomials. So you can't cross off the x squared. You can't take 12 and divide it by 4. That doesn't happen. The first thing we need to do with these, if they are any sort of polynomial, so binomial, trinomial, anything above that, is we are going to factor everything as much as possible. So that factoring stuff that we've been working on, I told you, these are the types of questions that are going to make you either love or hate that factoring stuff. So x squared plus 7x plus 12, we're going to factor into x plus 4 and x plus 3. And in the denominator, when we have just two terms to factor, we're always going to be looking for a GCF. So they share an x in common, and left-hand side is x plus 4. So you can choose to simplify now and then write restrictions, or you can write restrictions and then simplify. So for our restrictions, I'll come down here with those. We know that the denominator, x cannot equal 0, that part there. If that's 0, then the denominator would be 0. And in this parenthesis, if negative 4, if we put negative 4 in there, negative 4 plus 4 is 0, and that would give us 0 for the denominator. So there's our restrictions. In terms of the simplifying piece, we're going to cross off things in the numerator and the denominator that are exactly the same. That means if we have an x plus 4 divided by x plus 4, those would give us just 1. Okay, so that means that we have x plus 3 left. If it helps you to keep track of it, it is in parentheses. You don't need to write it as such. And then we just have x in the denominator. These x's cannot cross off because this x is part of a binomial and this x is part of a monomial. Okay, so binomial and monomials cannot cross off with each other. So here's the simplified answer. Here are the restrictions. Let's look at one more. So we have x cubed minus y cubed divided by x cubed minus xy squared. Okay, so any of our types of factoring that we've seen so far this school year can come into play here. So hopefully you recognize and you haven't forgotten about the difference of cubes because we have x cubed minus y cubed. That's where we have the little parentheses. So we're going to take the cube root of the first term, keep the sign, cube root of the second term. It's our little parenthesis. In the big parenthesis, we're going to square this first piece, so x squared. We switch the sign and multiply these two pieces together, so xy, and then we square the second term. In the denominator, I noticed that I can take a GCF of x, but left inside we would have x squared minus y squared. That's a difference of squares. So our x stays here. X squared minus y squared we can factor into x plus y and x minus y. Okay, so before we cross things off and simplify, let's look at our restrictions. Well, here, that would mean that x can't equal 0. In this one, if we tried to figure out what would make that equal to 0, it would happen if these two were opposite signs from each other. So if I have positive 1, then y couldn't equal negative 1. Or if x was negative 3, then y couldn't equal positive 3. So x can't equal negative y, the opposite of y. And for this one, x can't equal positive y. Okay, so if I have 3 and I subtract 3, that same number, it's going to give me 0, not allowed to happen. Okay, so those are our restrictions. You could also write this as x can't equal 0 and then plus or minus y. You can combine those together. Okay, all right, so crossing things off, the x minus y is the exact same thing in the numerator and the denominator. This is a trinomial. That parenthesis is not the same as this parenthesis, so you can't cross that out. And this is a monomial, and that can't cross off with parts of polynomials. So in the numerator, we have x squared plus xy plus y squared. In the denominator, we still have our x and the x plus y. This is our simplified answer. And here are the restrictions. And that's it.